Hey everyone, in this next part in our inequalities chapter, we'll be looking at algebraic fractions, alright? It's a rather simple technique actually, but I'm going to show you the wrong method first. Now let's say we have x minus 1 over x plus 2 greater than 0. Now what you might do is, hey, I'm just going to cross multiply to get x minus 1 greater than 0, and then hey, x is greater than 1. Now, it's completely wrong. Why is that so? By cross multiplying, you are assuming that, hey, x plus 2 is greater than 0. So because if x plus 2 is greater than 0, then for the whole function to be greater than 0, yes, x minus 1 is greater than 0. But x plus 2 can be negative, right? In that case, x minus 1 must be negative for it to be completely positive. Worse still, you also forget that x plus 2 cannot be minus 2. Sorry, x plus 2 cannot be 0, where x cannot be minus 2. Because if x plus 2 equals to 0, you're dividing by 0, which is undefined. Therefore, what you should do is consider our critical values when coming to solve algebraic fractions, alright? So what do I mean? So let's say we have x minus 1 over x plus 2 greater than 0. The idea of critical values is that find the denominator where the denominator gives us 0 and find the value such that the denominator is also equal to 0. So in this case, right, we have 1 and minus 2, right? The numerator is 1, the denominator is minus 2. Now, why do we consider critical values? We consider critical values because we want to see how the factors in either the numerator or the denominator would change in terms of their signs and thus cause the sign of the function to change. What do I mean? Let's see we have x less than minus 2, right? After all, you see 3 regions being split in this number line. So let's consider x less than minus 2. Where x is less than minus 2, our denominator is minus, negative. Our numerator is also negative. This results in our function becoming positive, therefore plus. When we now consider x between minus 2 and 1, what happened? Our denominator now changed to positive, right? Because we have crossed the critical value, one factor in our denominator, which is, well, happens to be the only factor in our denominator, x plus 2, has now become positive. Our numerator remains as negative. Therefore, this results in our entire function to be negative. And this is where you see that, hey, critical values is actually important because we are able to actually split the number line into many different ranges of x and then see how the resulting signs of each factor would affect the overall sign of our function. So from here, right, what should we also need to do is that which critical values can be considered as a solution and which critical values cannot be a solution, i.e. to say which values would cause our functions to not be undefined, which values would cause our functions to be undefined. So in this case, we know that we cannot consider minus 2 because we cannot afford to have our denominator to be 0. But in this case, we can consider 1 because because that is the numerator. But if you notice, right, our inequality sign does not include 0. As such, our solution is simply x less than minus 2 and x greater than 1. Alright, now let's take a look at another example where we have more factors. So let's say we have x minus 1 and x plus 3 over x minus 4. Alright, let's say we now have less than 0. Alright, now what do? Consider critical values. Okay, we have we have minus 3 first, minus 3, 1, and then 4. Now, let's consider x less than minus 3. When x is less than minus 3, what happens? X minus 1 is negative, x plus 3 is negative, x minus 4 is also negative. As such, we have negative times negative over negative, overall is negative. And actually from here, right, you are just able to actually just, hey, it's just alternating, right? Negative, positive, negative, positive. Why is that so? The idea is that when you plant critical values, every time you are crossing over a critical value, you have changed the factor, the sign of a factor. So in this case, when you cross from x less than minus 3 to x more than minus 3 less than 1, you change the factor x plus 3 to negative to positive. Same thing for x between minus 3 and 1 to x between 1 and 4. When you go from x between minus 3 to 1 to x less than 4 and greater than 1, you change the sign of the factor x minus 1. Then you change x minus 4 in this sector here. Therefore, our solution is simply x less than minus 3 and x greater than 1 less than 4. Now, what happens if we now include the 0, right? Less than or equal to 0. What do we do? Well, we now have to check whether our critical values will be allowed in our function. Basically, if you notice, x minus 4 cannot be 0, so we can just exclude 0, x equals to 4, and include 1 and minus 3. Therefore, our final solution would now be x less than or equals to minus 3 and x less than or equals to 1 but less than 4, because we cannot have 4 as our solution.